Good morning, good afternoon, everybody. Thanks so much for joining this next episode of In the Nick of Time. Today we have a great lineup. It's a pretty unique show. We've never had 6 guests before on the same episode, so it's going to be pretty amazing. You're going to learn a lot today if you want to really understand embedded systems and the challenges when it comes to moving at a pace of relevance and really embracing DevSecOps and digital transformation. This is going to be a great episode for you. Of course, it's recorded. You're going to be able to watch it on YouTube Live, on LinkedIn Live, Twitter, and Facebook, but it's always also saved on all of these platforms. Obviously, easier to find on YouTube if you want to easily search us on youtube.com/Nicolas Chelon. So, of course, if you have not subscribed, you need to do that. But first, I wanted to remind everybody to subscribe to the mailing list in thenickoftime.tv. If you've not done that, that's how we send you notifications about the next episodes and videos. You're not getting spammed at all, so don't hesitate to do that. Also, like we talked about, if you want to find the previous episodes and videos, it's going to be on youtube.com/Nicolas Chelon. So here you're going to find all of the videos, but also the technical videos that we do, deep dives on different topics like Kubernetes, Service Mesh, GitOps, and so on. Today, before we get started, we have a quick announcement that's going to be pretty exciting. It's something we've not talked about much before, but we've been working behind the scene, and I've been insisting and telling people that everybody needs to learn and spend at least an hour a day to not only catch up but keep up with the crazy pace of IT. So if you want to do that, we're going to be launching in August a series of curriculums. So you're going to find customized curriculums for developers, operations guys, site reliability engineers, CIOs, CEOs, CTOs, CISOs, cyber guys. And so we're going to really create training and we're going to create customized video segments. It's mostly going to be video driven, but we're also going to have a community of practice and an ability for people to ask questions live. And there's going to be live events private events. Of course, it's a subscription module. So you'll be able to subscribe. It's a monthly fee to get access to the unlimited set of videos and training. But more importantly, I try to partner with universities to do this, but most universities refuse to update their curriculums more than every 5 years. And of course, that's not going to fly when it comes to DevSecOps. And I don't want to have my name associated with obsolete training. So we committed to update the training every year. So that's going to be something that's continuously evolving, plus a new video segment per week on top of the community of practice and even some sessions one-on-one and different options there. So we're going to be launching this. Learn with Nick right now is the name. We're going to launch this in August. Doing a lot of recording now with over 45 segments already in the curriculum, covering everything from the culture stuff with how to create an enterprise team and decouple your platform team from your mission teams, and how to educate your leadership on the importance of DevSecOps and build momentum. What is chaos engineering? What is GitOps, DevSecOps, cattle versus pets? How to move from a monolithic architecture to microservices, how to use a strangler pattern, shift left, how to balance cyber and innovation, how to enable your teams to focus on mission software, how to make sure you're not building software in a vacuum, continuous software accreditation, and a lot of pretty awesome case studies and technical deep dives, enough to be dangerous, probably not deep technical deep dives, but enough for most people, including marketing, sales, and non-technical teams that want to understand all these concepts. So it's going to be a lot of fun. I'd love to get your feedback. At some point, we already got a few people piloting the training to give us some real-time feedback, and I think it's going to be pretty good stuff. So wanted to let you know that this is coming early next August. So stay tuned for that. Today, like I said, we have a pretty unique show because usually we have 1 or 2 guest maximums, but we have a pretty special topic. And so I had reached out to FedEx from the Air Force, and FedEx has been awesome. He's been leading a lot of the work when it comes to embedded system and really thinking differently to enable those teams to embrace the principles around agility, DevSecOps, and digital transformation. And so FedEx kind of put a pretty amazing lineup of people today, and I'm going to do a quick intro before I give a couple of minutes each for them to introduce themselves, and then we're going to get into the meat of the topic. So if you have questions about embedded systems, make sure you start typing the questions, because we already got a lot from LinkedIn and also Twitter. So we already have a lot of questions. So make sure you start typing now. Start with a Q in the comment section below, so we can answer those as soon as possible. So first, we have Felix Cortes. He's a product owner in the Air Force. They always have other non-fancy title, but that's how we like to think of Felix. We have also Jorge Ramirez. He's an acquisition program manager from the Air Force major, I believe. We have John Weiss. He's the director of software engineering at Tangram Flex. Michel Chabrou, another French person like me, senior director product management at Wind River. Mike Vondrak is a senior FAE at Wind River. And we have Brian Rochelle, the business development manager for MBSC for modeling at Ansys. So all of these bring pretty unique backgrounds, and I've been working these problems for many years. I'm going to start first talking about your journey in a couple of minutes, because we have so many guests today with Felix, and then we'll move to Jorge and we'll go through the list. So let's get started with you first. Welcome, Felix, to the show. Thanks so much for helping us put this lineup and for all the work you've been doing, really empowering the warfighter and making sure that we can keep up and even win the potential fight against China. So first, over to you in terms of your background.
Yeah, so thank you for having me. It's a pleasure to be on your show and bringing this topic to light. We've had many discussions in the past about this. Before we get started, though, I'd like to give a small disclaimer. The views and statements said during this discussion are my own and do not represent the Department of Defense or the United States government. That being said, my journey, I've been doing embedded all my life. If you're in the community, it's a small community, but hopefully we bring it more into light. I started as an electronics engineer with a software background over a decade ago. Let's not go with a specific date, but I've been with many contractors in the past, and I'm excited to share my experience to push innovations in the embedded space.
Awesome. So you put a pretty amazing lineup today. So let's go first. I like to stick to the government people first, because that's what I like better, but whatever. So let's go. I'm going to bring, here we go. So it's going to be a little bit painful to swap people, okay? But bear with me. It's just too many to bring on the same screen. So let me do the tweaking first. And here we go. Let's have Jorge give us a little bit of background first.
Hey, Nick, how are you? It's great to be with you. I do appreciate you bringing us on and having a discussion about embedded systems. I've spent 14 years active duty in the United States Air Force. Much like Felix, though, I do need to stipulate that anything expressed during this conversation are my own opinions and not a specific DoD or Air Force policy or directive. So I've had the opportunity to work everything from small satellite design and launch all the way through to advanced munition development. A lot of great teams along the way and a lot of fun along the way. So I'm excited to hear what our panel has to say today. Thank you. Yeah,
no doubt. All right. So let's see. Now we're going to go to Michel. So Michel, let me bring you up. It's always going to be a little bit like that. I'm sorry, but there's no design for 7 people on on this platform. So let's do that. All right. Over to you.
Hey, hi, Nick. So thanks for having us here today. So, I don't have to disclaim too much. I've been working in the critical infrastructure for about 20 years, served a lot of our customers in the Southwest for about 15 years. And I've been in product management now for about 10 years, looking at how we can essentially bring innovation in the embedded space, primarily in aerospace and defense market, as well as industrial, and now more recently in automotive. So looking forward to the conversation and very happy to to make sure that the latest technologies are available in an environment where traditionally people see as maybe being a little bit more resistance to this innovation. But there's definitely a lot of changes in the air today.
Yeah, no doubt. It's going to be pretty interesting, right? With Wind River being acquired by an automotive company, I guess that opens the door to a lot of different options. So pretty excited about that. All right, so now we have Mike here, the senior FAE at Wind River. So let's bring you now for your background.
Sure, Nick. Yeah, so I've been an FAE for 25 years and over 20 years at Wind River. So I've worked in a lot of different areas.
And tell people maybe what an FAE is, in case they don't know what an FAE is.
Field applications engineer. So I spend my time out in the field helping our customers understand how to utilize and design around our products, get things running, proof of concepts, that sort of stuff. So, and so I've been doing that for over 20 years with Wind River, and worked in networking, industrial, automotive space, and for the last few years in aerospace and defense, and specifically with the Air Force, and had a chance to work with Felix and his team doing an evaluation of our studio developer product. So, and I think that went well, and happy to talk about that, and happy to be on. Thank you.
Yeah, awesome. Thank you. All right, so now we're gonna bring Brian. So let me do that. It's always going to be fun, but here we go. All right, Brian, over to you.
Hey, Nick, thanks for having me today. Definitely excited to spread the good word on the technology that Ansys offers. I've been with Ansys for about 5 years now, and prior to that, I've worked in the defense industry for over 2 decades. I'm afraid to admit. I started off as an engineer, worked my way through the hardware engineering, hardware systems, and hardware engineering roles. Eventually, to find myself here at Ansys. So yeah, definitely excited to talk about some of our modeling capabilities to support very efficient development of embedded software applications.
Yeah, so we'll talk about how this is doable, right? Because people say it's not, but we're going to prove them wrong today. Okay, so now we're going to bring John. So for people that have seen, that we had another guest that was supposed to join Mark, and I think there was a last minute change. So John, we're lucky to have you today. Let me bring you up properly on the screen in a second. There we go. All right, over to you.
Hey, Nick, thanks so much. Great to meet you. Great to be on the call today. I'm a director of software engineering at Tangram Flex. I started on the founding team here in 2018. My role here is to help build out the delivery of Tangram Pro, which is our core software offering for engineers to develop, design, deliver component-based systems, especially where embedded systems are in play. I've spent the last 15 years working in the software development space, running everything from front-end engineering, back-end engineering, developer operations. So I'm really passionate about giving engineers the tools that they need to get their solutions out into the field. And so I'm really passionate about bringing cloud-native technologies to the Department of Defense. And the challenges we're going to talk today in the embedded space are really interesting to me. So thanks.
Yeah, it's pretty cool also to have companies that don't come with 20 years technical debt trying to help us do this, right? Because that's kind of some of the problem we see, right? Is a lot of those companies have been building MBSE products and different kind of embedded software products for so many years that they have a tough time, taking a step back and trying to see, hey, should we reinvent ourselves and come up with a fresh technology stack? And so that's good to have companies like you that are more recent, I guess, that don't come with all this baggage. I guess I like that a lot. But all right, so let's see. We talk about the journey. So now I'm gonna start with our friend here, FedEx, because he's the one who got us in trouble today. Bring all these people here. So for people that don't really understand all the nightmares you live through and that you have to worry about, tell us a little bit about the embedded system development and also, of course, the challenges that you see that we're facing.
Yeah, so I'd like to start by saying, when we talk about the word embedded, it carries lots of connotations to different people. So I think the first thing we should do is sort of give a little bit more details. What's that?
Yeah, defining it. Yeah.
Yeah, so everybody has a different definition. So at a minimum, what I think people should do is denote sort of a delineation a little bit more than just the word embedded. So I suggest using what type of hardware architecture you're using whenever you're having a conversation, whenever you're actually using that definition. So for this conversation, let's say anything that is not x86 on your desktop or in a server somewhere that uses x86. So that being said, we can talk about 4 specific challenges that we're going to highlight today, although there's probably tons and tons more. So the 4 challenges I want to talk about is the first thing is when we typically talk embedded, we have things that we have to do in terms of considerations for space, for weight, for power, and for environmental constraints. So you can think of a handheld device as operating on a battery. It can't be too heavy. It has to fit in your pocket. So that right there is a challenge because you're going to trade off potentially performance or something else. What that does, though, is that kind of makes your hardware a little bit more unique, and therefore you have less support for that hardware. And that support, you need somebody to develop software for that more unique piece of hardware in terms of operating system, drivers, board support packages. I mean, the list goes on and on. So that's the second.
What software can run on it, right? So all the tools
Absolutely.
we take for granted on the x86 universe and cloud, the normal non-ARM stuff and non-embedded stuff, I guess you're limited in tools and options, right?
Your tool chain becomes more limited as you become more niche on your hardware because of that support that you have. That's absolutely right. And as that's happening, now we talk into a more, specific area where you talk about safety, like in cars or avionics, where you have certification requirements for that hardware and that software. So we continue to add another layer of uniqueness to that hardware. So that burden alone makes it really hard to switch out that hardware and makes that tool chain even more unique. So that's the third challenge. And as we go to the last challenge is it comes into interfaces, right? Many times, if we have a very unique piece of hardware and we're developing software for that, many times we integrate that interface into the monolithic software application code itself. And so at that point, even if we have open standards, we just can't switch out hardware left and right, and it's stuck within the platform. When many cases,
tightly coupled. Yeah,
it's tightly coupled to the platform. Even if we want to go modular, the idea would be going modular from platform to platform, and that interfaces could be somewhat hard if that new platform is not using the same type of interface. So I think those are the 4 main areas that we can do a lot of things to improve within the embedded space.
And if you think of tangible examples, right? You gave a couple of good examples with handheld devices, right? But it's also like could be a satellite, right? Could be a jet, could be a car, could be maybe even a weapon, a missile. So could be a lot of different things. And of course, you're dealing with often disconnected states, right? So a lack of communication capabilities, often air gapped, right? So and then you talked about the secret sauce or special sauce chips, which leads to drastic consequences when it comes to tools, compilers, test suites, cyber tools, right? You mostly don't have access to what I like to call, I guess more common best of breed capabilities that we know on the DevSecOps side. Because of that, many don't support those chips, although you see some starting to do better, supporting ARM and stuff like that, but that's just a tiny piece of the iceberg. And so that's really a good example is SpaceX, right? That decided to use x86 options to be able to use best tools and stick to Linux open source, and they have a patch for real-time OS. And that's the other thing, right? You're also dealing with what many people don't even know about it, which is kind of the real-time constraints, right? And so give us maybe a little bit of insight as far as what that means for people that don't know what real-time requirements could be.
So many times when people think of real-time, they think of speed or something going fast. But really what real-time means is deterministic behavior. and meeting your scheduling deadlines. So,
Mhm.
you can rely on those guarantees. The example I like to
Yeah.
give is an airbag, right? You don't want your airbag to deploy too early, or you don't want your airbag to deploy too late, because either way, it's going to be fatal. So, so we like to rely on real-time systems and real-time software because we have a high rate of success, greater than Six Sigma for that to happen.
Right. And so there's different hard and soft constraints, right? And so depending on the
Mm-hmm.
criticality of real time, the deterministic aspect, right, is effectively saying, if you trigger it, is going to happen within this time frame, and the hard requirements of effectively it's a timing. Is it like a very specific maximum amount of time by which it has to run, or how do you define that deterministic aspect, I guess?
Yeah, I mean, that depends on your system. That depends on your system engineer and your requirements, right? Maybe an example would be if you're watching Netflix, and how okay are you with restarting Netflix, and how many customers are you willing to lose if you're waiting 10
Hmm.
minutes to restart every single time? So there is you do case studies, and you have to do an analysis, but Netflix has determined they need something relatively stable, but maybe not necessarily something firm, right? Maybe something less than a minute would be okay.
Yeah, it's like my plane, right? My IFD and my PFD starts pretty quick, but my MFD, which has the less important information, I guess, takes a little bit more time. So I guess there's more features. There's the map stuff and all the bells and whistles of the plane, but my PFD, my principal screen for my glass is starting almost within a second. So you could reset the breaker and have a fresh experience, almost like rebooting a server, but in a matter of seconds. And you see it, right? It's the same, right, with cell phones, right? You remember how long it used to take for cell phones to boot, and they drastically improve the time it takes to get to the welcome screen, right? That's the kind of thing that people care about, and it's obviously important to the user experience. But for phone days, no one is going to be, well, usually at least, no one is going to be dying waiting for. Maybe if you trying to call 911, that could be a different story. But at least most use cases, people can wait a few seconds to have a phone stop. But of course, when you start touching space systems and jets and weapons and things like that, obviously now you're talking time sensitive. And one aspect that I kind of always struggle with is the people building these capabilities often get stuck into the real-time OS world, even when they don't need it, right? And so I've seen people like fail to decouple, the stuff that really needs to be running on those chips and those real-time OSs, and maybe some modern, AI ML capability or whatever the case may be that could be running potentially on something else. So that's also an interesting kind of learning and thought, right? In terms of, okay, what hardware are you bringing on the system, and is it swappable? Is it something that are we thinking cattle, swapping hardware easily? I remember in the ship, right, with the Navy, they were struggling to swap, kind of a rack of compute and storage, where really that should have been pretty basic, cattle concept of like swapping a rack and putting a modern one and swapping the hardware with a better hardware, but they were very tightly coupled to what the hardware was. So I assume you're also thinking about these kind of challenges of using the best tool to get the job done.
Absolutely. So, I mean, what you explained is a common problem just about everywhere in the embedded non-x86 space, because we are limited in tool chains, because we're limited on what we can do with certifications. So a simple swap sometimes isn't so simple, right? Because you've already invested so much in that tool chain. Maybe that tool chain went away, 10 years ago, and you
Right.
no longer have support. So how do we get beyond that point is that's the question, right? That's why we're here today is how do we do that? And, one of the last ones we talked about was that monolithic software that we have traditionally. So, are things over certified? Are things overdone in some cases? In a lot of cases, yeah, absolutely, because of those constraints, right? Because you have that monolithic software, and we haven't seen in the last 10 years the ability to break that up. But I think times are changing, and it's really exciting to be a part of that.
And the expectation is changing, right? I think it's not so much the people, but more like what you end up seeing outside of your job, out of DoD, and now you're like, wait, I can do all this stuff on my personal phones and things in a matter of seconds, and now I go back to the dark ages, right, in the department doing outdated things. Often not so much because maybe of over certification, but maybe because of the lack of automation of those, which end up being massive bottlenecks. Where you compare that to a SpaceX, right, that can do 17,000 build of software a day and 3 hardware in the loop testing a day and update software hours before the launch. That's a massive enabler, right, of having a digital twin, having the ability to know how the software is going to behave, have the right test coverage to know if the changes you made, and ideally you do small incremental changes, right, to not break big things, and having the tests, right, to ensure you're not breaking stuff, and be able to then move at a faster pace without impacting security, just through automation, ruthless automation, removing kind of human bottlenecks just for the sake of humans. I would rather have humans focus on the more complex, harder to automate problems. What do you think?
Well, I think, yes, I absolutely agree on I think it's also what we need to think of is, what are these people doing right, and how can we learn from that? So you mentioned SpaceX, right? I'll even throw in Tesla, right? You're talking a specific platform that's continuously improved upon over and over again to a state where you can do code changes, right before it launches. But I think it's also important to note that standing up a new platform is extremely hard. I think we've seen that in the case with the Cybertruck, right? Like, there's a lot of challenges standing up a new platform, but when we take things that are existing and we improve upon them, like Tesla did from the Model 3 to the Model Y, why can't we leverage that type of capability elsewhere, right? And so
Right.
I think we need to focus on what things that work. Look at your portfolio and see, I have maybe 3 versions of an iPhone. Why am I having 3 different, completely separate platforms when they all have cameras, right? And you're starting to see embedded, manufacturers and software developers utilizing the same hardware over and over again because of some of these constraints. And I think we need to see more of that.
Yeah, so more modular, more flexible, and also like enabling reuse and decoupling and separating those constraints, and effectively when you run on specific chips, you're kind of stuck in the universe of that manufacturer, who often brings with him or her or the company, I guess, all the tools, right? And so the testing, the compilers, the different things, right? So that limits your options. You have less. You almost vendor locked to some degree. I mean, you're very much locked when it comes to diversity of software options, right?
I mean, what's even crazier is, the third parties, when they talk about embedded, can inject their own proprietary designs in the hardware itself. So if you wanted to switch out the software and you had the capability to do that,
you couldn't do it.
You couldn't do it because the third-party IP would prevent you from having access to those drivers for the software to communicate with the hardware. So a lot of times we don't catch that until after the fact, and it makes things really difficult.
So you think that the government maybe could do a better job at maybe in contracts, right? Make sure that that cannot happen.
I think understanding your system, having more technical experience, no matter where you're at, it's going to help, right? I mean,
yeah, because we shouldn't just find that out after it's too late, right? I mean, ideally you would know,
yeah,
right?
Any company should know, right? Or any entity buying something should know what you're getting. But it is tricky because embedded does have those extra layers of complexity, and
it's a very specific expertise.
Yeah. So absolutely,
and companies
I think there's room for
a little bit, right?
Yeah, I think improvement can be across the board in the industry. You're just bringing it to light, lowering the barrier of entry, and then exposing, digital and some of these other practices that, like today is how do we decouple that so it's less of an issue.
Yeah, and honestly, I think that kind of behavior is not going to fly much longer, and I think companies start to realize it, and I think trying to get people locked in for the heck of getting people locked in is probably not a good business practice for long-term successful win-win stories, right? So that might get you out of bankruptcy for another couple of years, but that's probably the extent of what you're getting with that kind of behavior, right? So, all right. So, it's a pretty grim picture, right? Talking about, say, if you listen to some people, particularly people that have a tough time reinventing themselves and thinking outside the box, which I think is probably a great example of what SpaceX did. I think that's kind of what makes Elon Musk pretty unique. He's always questioning, something that's always stuck in stone or something that's understood as a must-have. And then you're like, but why is it? Why is it a must-have, right? Is it really a must-have, right? Like using space hardware, he just dismissed that, and instead he created this capability to have multiple commercial hardware, and created an algorithm to decide, if some of the systems are misbehaving based on consensus. That's how they make decisions based on volume of consensus. So he really took things that were expected or the only way to do business and kind of thought outside the box. So you listen to a lot of I guess legacy teams. They're gonna tell you that the velocity at which we're moving is the best it can be, and then they see SpaceX and they're like, wow, this must be insecure, and so they see a few failures and they say, oh, see, it's not safe. Although people should know that none of the failure were software related ever. It was always hardware issues. But it's also embracing failing, right? I'm always worried when I see the government start to freeze work because there was one, launch that failed. That's not how you learn. If you look at China, 200 hypersonic launches, the US did 10. That's not good. You can't learn if you don't move fast enough, and you need to learn. And so fail fast, learn fast, and don't fail twice for the same reason. In fact, I just recorded the video on that segment for our training to really kind of explain to people what that means, right? To fail, to understand failing, but also to understand how you learn from that, and how you do small incremental failure, not big, massive, disastrous outcomes. And also then how do you make sure you don't fail twice for the same reason, because that's unacceptable, right? So are we just stuck, or what's the plan? What can we do? And can we even get to DevSecOps with embedded systems?
Yeah, so I'm optimistic. Innovation has always been part of this country, and I think that's how we get there. So I think with innovation and thinking smarter, and like you said, looking at good examples out there, how do we learn from examples like Apple, SpaceX, etc., right? How do we focus in on, what they're doing right? What can we bring in and replicate that? And so, I'm hoping as we bring in some other guests, we can make, a stronger case to bring that in the way that fits for, whatever industry or whatever you're looking at doing, just to make sure it fits. So broadly speaking, I think there's a few things if we talk on the development side versus the deployment side that we can look at. And, although there's multiple ways to skin a cat, I've seen what I think is most hopeful is hardware emulation. I think hardware emulation is a good starting point to decouple yourself from the hardware, because you don't have to have physical access to that hardware. So I think that's great. I think this another technology that I'm really liking and is multi-core and segmenting various applications with a hypervisor. It's not microservices just yet, but it is a way where we talked about certifications can be isolated, and we can put less critical things like a GUI on a separate CPU and kind of move forward. The next thing is model.
No, I said, yeah, go ahead. Sorry. keep going.
The next thing I see is multi-core, or sorry, aside from multi-core, I see model-based system engineering. And a lot of people think of model-based system engineering at the sort of the high level, the SysML level, but really don't think about software. And I think if you start to abstract software even further into a model, and you separate, say, the logic from the interfaces, and you decouple the logic from the actual hardware, now we're starting to talk about true abilities to move that application code between hardware without those dependencies. So I think that's a great way to go. You mentioned Linux and open source. I think that's also great. Linux or SpaceX has a team. I talked to the team out there who's supporting creating that kernel for them, and they have tremendous support. I think that's a viable option for a DAL-D or a DAL-C type of situation if we have someone who is kind of supporting that kernel. But lots of great ideas out there in industry. I think we can take all those. And so, yeah, hopeful innovation. I think it's going to get us to the finish line. And, I'm excited to see what comes out of it.
Yeah, and we're going to dig into the hardware emulation now with Wind River and the team. But one last kind of follow-up, right? First, I hope we're not just going to rely on Elon Musk and his teams to show us that it's doable in every market to say we can do this, because he's demonstrated it in certainly with Tesla and being able to update software and decouple the hardware from the software with over-the-air updates and ability to bring not just basic software update like you see on most dealers, but really and manufacturers, but really real new features, right? And that's pretty amazing. And it was, both the over-the-air update concept, which was non-existent in automotive whatsoever, and the velocity of update and the setting the expectation that, hey, you might be stuck in time on the hardware, but you're going to get new capabilities. And oh, by the way, we're going to get to self-driving together, which is even more mind-boggling, if you ask me. But so he demonstrated that on the automotive side, and then he did it on the space side, right, with the SpaceX being able to update software a day before launches, where often we used to have a freeze actually in the Air Force. So I don't know if you know, but I'm the one that kind of pushed back on this. The Air Force used to freeze 60 days, right? The launch of satellite launches, and so when we had a SpaceX launch with the Air Force, the software was actually more at risk because we didn't have access to the latest releases, because the Air Force had a 60-day freeze, which actually ended up putting us more at risk than not having it, right? So we removed it to have access to the latest versions of the launches, because they had commercial launches since then, fixed things, and because of the 60-day freeze, we couldn't put the fixes, which effectively put our launches at bigger risk than the commercial launches, which was, see how sometimes, kind of regulation and bureaucracy can actually be doing exactly the opposite of what it is designed to do, which was, allegedly make the launches safer by freezing the code 60 days before launch, which in this case was actually putting us more at risk. So it's always interesting. But tell us a little bit about what a digital twin is, because people have been asking that, and how would you describe it?
So there's again tons of definitions for digital twins. Hopefully my colleagues over here or my friends over here at Wind River can explain their version. But I like to say for software digital twins, right? You have physics models, but then you also have software, and I think it's for software is creating a digital twin of the hardware at the right fidelity to verify and validate software. Right. That's it, right? So, the idea of you having to need 100% digital twin and spending all this money, I don't think is necessary.
It's a metaverse, right? It's like you need to do the wind and the sky, and it's where do you stop, and what kind of degree of and can we really do we even understand the world enough to do 100% replica, right?
For software, we don't need to go down to the resistor or the capacitor, because you don't. The software doesn't even see that, right? So you have to trick the software enough to think it's actually working in a real hardware environment, and then that portion right there, that digital twin, really helps unlock continuous integration, continuous development, because you're no longer constrained to a hardware. And oh, by the way, usually the computer you're working on, which is an x86, right, now has the ability to test and compile, right there in front of your desk versus going into a lab somewhere. So I think that's huge.
Take 5 months to ship it. Yeah. And that gives
If you're
you, and that's
lucky.
kind of the point of the SpaceX model, right? They can do 17,000 build of software a day and the full tests on the digital twin aspect, but because of the limitation of the hardware, they can only do 3 hardware in the loop testing a day because the hardware takes time, to run all the tests. And so you have 17,000 build on the digital twin side, which gives you a lot of already great accuracy. And of course, the more maturity and the more detail and the more realistic, of course, your digital twin is, the more likely it is to be a right representation of what's going to happen in real life, obviously. So, we're not saying you don't want to be as precise as you can be, but you don't want to be over precise for the sake of it, right? But at the same time, I guess it has to be good enough. Otherwise, you never do anything. And then they have the hardware in the loop testing piece, where now it's running on the hardware to really make sure that it's behaving the same, and that's pretty cool stuff. So let's bring our friends now with Michelle and Mike, and I'm gonna move you up for a second, and let's dig into a little bit first. I think Mike is gonna share with us a little bit about really what multi-core and let's start with hardware emulation, because I think that's something people understand a little bit better. So if you don't mind, just telling us exactly what that is.
Well, sure. Here at Wind River, we support, as Felix was describing, digital twins. So we have our SIMX environment, and as Felix was saying, the important thing here is to make sure that it's capable and functional for the software. So you could go down, you could do emulation of every register, but then it would be very slow. Trying to do fully cycle accurate. So we're focused on making it viable and useful for the software developer, so you can integrate it with, DevSecOps pipelines and doing testing in parallel and so forth. So, that's really high fidelity from the software perspective.
Right. So you can effectively emulate different type of hardware, and you can put it not just in a lab, but that could potentially be on clouds too. Or what's the limitation, I guess, of where this stuff can run?
Sure. I mean, you can really run the SIMX environment on your desktop. You can run it in the cloud. We've integrated with our Studio, developer platform, so that you can actually have a virtual lab and integrate it with pipelines, so you can call them up and really from a single point, single portal access from a cloud standpoint, log in, start a build, push it to the digital twin test and get results. And you can even push that out simultaneously, even to multiple target types. So you want to test on x86, you want to test on on ARM, on PowerPC, all the various embedded type of platforms. So the ability to do that.
Software companies, it's a great tool for software companies that need to support multiple type of hardware, right?
Exactly. Yep.
Yeah. And so what's the difference, I guess, with multi-core? What does that mean?
Well, I don't know. Michelle, you want to jump in here with respect to multi-core? I know you had some thoughts around that and containerization.
Yes, so one of the elements, and I really like Felix's point here, the idea is to reach the right level of fidelity, and with multi-core, it's the same thing. If you're going to use software simulation of hardware with software to verify your software, your own application software, you want to have the right level of fidelity. And today, we're entering a world where everything is multi-core. So we need to also enable that functionality within a digital twin environment. And that includes some of the features that Felix mentioned earlier, the ability of to leverage virtualization to run multiple instances of operating systems on a digital environment. So Nick, you mentioned we need to use the right software for the right thing. So AI/ML would use Linux, and you could use a real-time operating system for whatever feature function as you need. But now you can have that multi-core emulation that allows you to run that hypervisor. Then on top of that, you can run your various payloads however you see fit, right? So by combining both of them, in a cloud native environment, now anyone can actually run different payloads, validate different types of payload directly from a desktop without having the need to have an actual board on your desk, right? So that gives you that extra level of flexibility, cloud native access of simulation of hardware with the ability to run multiple payloads.
That makes sense. That makes sense. So we got the emulation piece. Obviously, you guys, have been working on something pretty unique. In fact, very much early compared to most of the competition out there. When you decided to start supporting Kubernetes and containers on real-time OS, and that was a pretty massive undertaking. Why did you do it, and how?
The why is actually a good question. It took a while to actually pull the trigger on this. We've had a lot of conversations with a lot of customers trying to look, in the future. Some of the elements you brought up earlier, and as well Felix brought up, was the ability to move away from a monolithic model for the applications. The question has been, how would we do that? And obviously, so well, let's look at the world. How did the world make it? And obviously, we go to the world of cattle, right? The IT environment where everything is a blade, is an x86 server somewhere. And there was a whole lot of technology and innovation that had been poured into this environment. The question is, can we do the same thing in an environment that, to Felix's point, has a lot of constraints and become essentially the pet, right? You mentioned earlier the pet versus cattle, right? You have all these servers, and then in an embedded environment, very traditional, each device is very unique in nature, from the handheld device to missile to everything in between. And the thing is, it kind of dawned on us that, well, there's no choice. We have to find a way to bring this amount of some of this technology into the world of embedded. So just like we mentioned about hardware emulation, it's not a one-size-fits-all. We decided to look at the specification for containers and try to understand what portion of these specs do apply to a more traditional embedded environment. And so essentially, we actually had an approach that was more of a refining approach. Instead of just making a blanket statement that everything shall be available within an embedded environment, is what is useful to the end users? What is useful to our DoD customer? What is useful to our industrial customers, obviously, as well, and automotive? And so we came up to with a subset of the container specifications. And we decided, we're going to have to re-implement it because we had some constraints. Felix mentioned certification. Our goal was to enable this container technology to be used in an aircraft where you have the highest level of safety certification, a DO 178C.A. And so we had to really spend a lot of time, and I don't want to say do it right because we're not finished, but essentially create a framework that allows us to have a baseline to assist in that decoupling and move away from the monolithic application into more of a microservice architecture. So this is an enabler. This is phase one. So how did we do it? Well, it was a whole lot of hard work and sweat, and our team spent a whole lot of weekends on it. But indeed, we're very happy to have been able to do this. And now we're working more with our customers into what is the next phase. How do we deal with orchestration? How do you deal with running software on a heterogeneous hardware environment and decouple even more so that you can swap the hardware more easily? I'm not saying super easy like in the IT world, but more easily, where it's easier. So it's a journey, right? And I want us to be able to go on that journey. I don't think we have put our foot beyond the finish line. As a matter of fact, I believe the finish line will keep on moving with us. But we're certainly looking for all feedback as to how we can definitely modernize and really accompany our customers from the development aspect of things using SaaS to all the way to the device where we leverage traits of the cloud native environment in a more bespoke, traditional embedded system.
So you mentioned the struggle with the highest level of certification and assessment. Where are you on that journey? Do you feel like you're getting close to being able to succeed at getting those approvals?
Yes, we are actually in the process of going through it. I will not be able to name the customers with whom we are working on it for obvious reasons, but we are working with actual customers to essentially have a real-time operating system type of container engine safety certified for being deployed in an airframe with the right level of evidence to satisfy the ESA and the FAA.
And you think so it's just a matter of time now to go through the process, or you still have to change things?
No, this is a matter of time. So we are done with some of the various elements, the stage of intent, the SOI levels. So we have done some progress here. So the design of the system is set in stone. It is available today as an off-the-shelf product, obviously. What is important is while it is a proprietary piece of IP, it is using open specification. So the Open Container Initiative specifications are what we're following, and we're making sure that we're compatible with tools such as runC. So if you're used to using Kubernetes as it is today, you do not have to relearn something else in order to leverage the same level of technology, like I say, in a more traditional environment. So at this point, it's truly a matter of time. Now, this takes a lot of time. So this is not for next week. I can promise you that. And unfortunately.
What are we talking about, you think?
I would say we will have probably all the evidences, and don't quote me on this because I don't have the planning in front of my eyes, but it's probably a mid to late 2023 for us to be able to have formal certification evidence. Now, that doesn't prevent you from starting the projects today. To be frank, it takes so much time to design this airframe software that if you start today, your delivery date is going to be post our availability of evidence.
Yeah. And so you better come back here to announce it when it's done, because I want to be the one breaking the news. That's number one.
I will let you know. Absolutely.
That's pretty cool, right? Because it will be a massive achievement. And how do you think about separating the need of true real-time software with other things that maybe a plane nowadays or a car or whatever is going to be doing that doesn't need maybe all the benefits of real time? How do you see that journey in Wind River, and how do you help customers kind of think about splitting potentially the two, or at least enabling kind of the use of non-real-time software?
That's a very good question. And I think Felix brought the seed for the answer here is the technology to do that or exists. It is to leverage true hardware virtualization. So the hardware today is powerful enough and has the design elements to enable the end user to truly put multiple heterogeneous operating environments in the same box. So you can essentially now be very purposeful and intentional in how you partition your application between this true real-time software and this less real-time software, or more open software. There's element of a system that will remain for the next few years kind of very closely guarded proprietary, but there's going to be some open source elements such as machine learning. And what's interesting with machine learning is now with the virtualization solutions we provide with our development environment on the DevSecOps, we have a set of assets, different types of platforms to put on your hardware. Now you can run multiple instances of Linux alongside an RTOS, right? Multiple instances of an RTOS alongside multiple instances of Linux and Android for that matter in the near future. So you're looking at being able to deploy a full operating environment that is completely open, like we've discussed Linux, next to a completely proprietary environment or mix of both. And the beauty of this is that doesn't mean you cannot have them communicate as well. So you could do the AI ML on your Linux environment. And because the entire system is safety certified as well, then you can communicate between your Linux environment, and you can have the AI and machine learning be an input into a more critical part of the systems, like controlling the landing gears, for example. Felix used the airbag as an example. When you want to land, you want to make sure your landing gears are deploying when the pilot, wants to deploy them, right? So some of the elements of the airframes have a type of SLA, if you will, that is different than some others. And by being able to combine them in one box, you can now address the swap issues, the space, weight, and power, as well as the ability to bring in this modern development, this modern construct into a more traditional world. To close on this, the software that we use, this asset that we have, is also being certified to DO-178C DAL Alpha, and we intend to have the evidence available by the end of this year, so by the end of 2022. And this is an environment, as I said, where Linux and proprietary will be able to coexist, completely side by side, collaborate, and enable these new workflows. Also containers. You can use containers in Linux, you can use container in the RTOS. Using virtualization doesn't preclude you from doing this, move away from a monolithic environment. So it gives you multiple aspects of decoupling from the low level of the hardware all the way to the high level of the stack.
Yeah, that's very cool. And I can tell you, as I have a retractable gear on my plane, and I still look at those 3 greens very carefully every time we're landing. So I certainly understand of the importance of the landing gear. I don't want to do a belly landing anytime soon. So, all right. So we talk about I guess really the first main engagement of Kubernetes and containers on real-time OS. We're gonna move now to talk a little bit about how do we go about developing software and abstracting it from the hardware. And so we're going to go back to FedEx, but we're going to bring also our friends from Ansys. So Brian here, I'm going to pull you up. All right. So FedEx, when you think about developing software and abstracting it from the hardware, how do you think about that problem when you're thinking about the design and architecture of the software?
Yeah, so I mean, traditionally, if you are going to start software and you have a hardware constraint, you have to think about that first, right? It's hard to get started if you don't know what's available to you. So what drivers do I need? What libraries do I have available to me? Like, do I even have Python available to me? So even if you do get started, there's a high potential for rework if you don't already know your hardware. And that really shouldn't be the case, because your logic usually has nothing to do with your hardware unless you are looking at a hardware solution, in which case you're talking FPGAs or something else. So,
right.
So in my opinion, I think the architectures become, you're no longer shifting left. You're kind of just waiting on things to see what you can do, and what do you have available when you do have access to it. So one idea is, if you just focus on the logic itself, which a lot of times we do at a system level, then what's the harm there? So there shouldn't be any harm, but how do you take that a step further? And how do you take SysML, which is that high-level system architecture, into a software requirement, a deep dive? And what does your software architecture look like in that arena? Many times, in the modeling realm, we talk about state machines, not necessarily when we talk about software architecture. So there is a change there. I think it's for me, I find it interesting, because that's as a developer, as someone who's working on this, that's the part that you want to focus on. Not, once I finish my software, is it able to run? And if it doesn't, why doesn't it? Is it a hardware problem, or is it a software problem? And if those are two different teams, you're kind of pointing fingers at each other sometimes in terms of who's at fault. So
right, yeah,
that's kind of how I see it kind of going there.
Yeah, no doubt. I guess same question to you, Brian. Do you have anything to add to this question?
Yeah, certainly. So when you're developing a software-driven complex system, right? You can think of that system as consisting of several layers. You have the hardware layer, of course, and maybe an operating system or a real-time operating system. You may also have some interface drivers or I/O drivers, but sitting right at the top is the software application. And so, really, one of the first jobs a system engineer does is to decompose that system into the different components for development, including the software component. And so this is really what the capability that Ansys has. It's called SCADE. It's a development environment. It's a model-based development environment meant to really efficiently tackle complex, embedded, safety-critical guidance, navigation, controls, or display or human-machine interface type applications that are really meant that have a high cost of failure, and they're really expensive to find failures further down the development cycle. So to be able to do this efficiently, I guess some would say, is the holy grail of embedded software development. We've had this capability. It's tried and true. It's been around for over 2 decades. The language itself is really, it's a synchronous programming language. So it's meant to support developing applications that execute at some predefined regular interval real-time systems, right? And that's really the benefit, is to be able to develop, to test with a high degree of confidence and simulate within that environment that your application is going to behave exactly as intended. Because the challenge and the pain oftentimes comes when you have to marry that application to the hardware. You might not even have the hardware. Maybe you're going to test it virtually, or you may not even know what the hardware is, right? So you may be developing an application that will be hosted in someone else's platform. So those are risks that can certainly be mitigated in the environment that we offer.
And how do you run it? Can you run it on a cloud? Is it just on the desktop, or how do people go after this, I guess?
Yeah, great question. So the secret sauce under the hood of the development environment is in the code generation, right? So we develop this code generation. It's qualified to various standards across different domains, including aerospace and automotive and industrial, to produce human readable source code to a standard that has strong consideration for safety. So it's an expensive process to qualify any kind of software. So we develop it to be run in a Windows environment. It can be on-prem on your laptop, or it can be hosted in a VM in the cloud. The process itself, it doesn't really matter if you're developing to a traditional waterfall process, the V curve, or if you're developing to a continuous integration, continuous development environment, CI/CD, right? Or within a DevSecOps environment. None of that really matters. The tool is agnostic to the process in that sense.
Interesting. I guess it doesn't matter to the tool, but it matters to people's success. But that's a different story.
Right.
So now we talk about I guess that streamlining, right, of the certificate and the complexity and the expensive and the lengthy process of certification. How does I guess your modeling and your emulation allows to make sure that you accelerate that certification process?
Right. Yeah. So when you're developing, these applications to these high design assurance levels, DAL A being the highest complexity to the aerospace standard DO 178C, there's a very rigorous development process associated with that, right? And the idea is that you're generating artifacts and evidence to prove to the certification authorities that you're creating this so-called paper trail to prove that you've developed this software in a very thorough way with high confidence that there will not be any unintended or unsafe consequences of that software failing. And so the process can be expensive. And if you can automate that as much as possible and reduce your costs, then you can certainly bring that product to market quicker, certification quicker, boost your productivity, right, and manage greater degrees of complexity more efficiently. And so for us, within the capability we offer, within the technology called SCADE, we have the automatic source code generation from those models. It's qualified to the highest tool qualification level under DO 178C, DO 330.
It's already, is it already passing, or is it already certified, or is it just passing, or is it what do you get with that code?
Yeah. There's 2 pieces to developing and certifying an application. There's the tool and then the application. So we address the tool qualification. So you have a high degree of confidence that the application you're developing is really going to be is going to have certifiable source code generated from those models, and all the evidence and artifacts, the paper trail, will be automatically generated from that tool set.
Okay. So that's a massive enabler, but then you have the other aspect of it, right? We talked so much about reuse and reuse of code and capabilities, and so how do you guys could help maximize that reuse there?
Yeah. There's certainly ways to reuse on the application. Of course, it's abstracted from the hardware, right? So there's different approaches like product line engineering. There's within the defense industry, there's this modular open system approach. It's as MOSA as it's referred to, where you have standards that are meant to define the interfaces in a way that's abstracted from the hardware, and we can support those standards. There's standards like FACE, like OMS, and then there's also the interfaces that are defined could be specific or slightly coupled to that system, and this is where some of the capabilities that are offered by Tangram Flex with their product Tangram Pro could also be a benefit.
Yeah, no, that's great. And I want to bring John, of course, in that discussion because this is directly related to the work he's been doing as well when it comes to that reusability of code and capabilities, which is kind of essential to improving velocity of work and stopping the waste of redundant work. So, John, when you think about reusability and of code and all capabilities or containers or Lego blocks or whatever you want to call them, what do you think about?
Yeah, that's a great question, Nick. I think about this in a number of ways. It's relevant in the embedded system space, but I think it's helpful to reflect on some of the wins that have happened over the last few decades in industry and take a step back for just a moment and consider the why behind why those wins were achieved and those technologies were adopted around code reuse. So I think of immediately Git, Node, and Docker, right? Git is arriving on the scene in 2005, but it doesn't really take off until you have an ecosystem in GitHub in 2008. Same thing happens in JavaScript with the Node revolution in 2009, but NPM comes in 2010. If you look at NPM, it has the same fundamental technologies that exist with regard to Perl or Python. It's a scripting language. It allows for software modules, but those technologies came before GitHub. Node comes after GitHub. The same exact thing happens with C groups and Docker containers, which has led to the cloud native revolution. You've got C groups coming into Linux in 2009, 2008, but then Docker Hub arrives in 2013. Docker and Docker Hub then create the revolution that we're all kind of continuing the wave of. So I think it's a pattern that has to be understood. You have two aspects to that pattern. You have a technology that allows you to encapsulate the functionality that's delivered. And then you have a network effect that allows you to deliver, version, and discover that modular component functionality. So if you have those two things in play, I believe you have the necessary ingredients for the markers of what allows for code reuse to change an ecosystem or an industry. So I think, we've heard from Wind River. I was really excited to hear what they're working on. I think some of these technologies are at play here, but I think in the embedded world where the reuse happens is exactly what they were referring to. Understanding where your system is partitioned between the embedded component and the larger ecosystem of where that component plays. So I think the reuse comes right there. We articulate how does that embedded component interrelate or interoperate with the rest of its ecosystem. For example, it might be a radar component, it might be a cockpit display. What are the standards and interfaces that component needs to use to speak to the broader ecosystem? So I don't think it's just enabling reuse in the embedded component itself, but also in its larger context. So I think we need to build networks, we need to build tools which allow you to version, deliver, encapsulate that component functionality, but then discover it and swap it out, right? So you're right there in the intersection between the embedded component and the larger system. So I think what's necessary is looking at that entire system, just like we do with infrastructure as code. I have this embedded component, I have this larger ecosystem, I can version, variant, and deploy all of those things. And really understanding not just those components, but the interfaces between those components and the broader ecosystem they play in.
Yeah, no doubt. This is so important, right? And when you think of a sensor on the ship that could be reused on the plane, right? You talk about the interface. You talk about potentially, I guess, a container would be a great way to ship it across different teams and make it discoverable. Maybe having some documentation on how to consume the container, right? What's expected, just like an API, right? What you expect in terms of ability to exchange information or react to whatever it's doing. So when you think of that kind of interface, interface that's required, right, to enable that communication, there's kind of two train of thoughts, right? Of course, some companies are pushing for this, one interface to rule them all, so everybody will stick to a standard, and that would be the way to go. Obviously, if it's an open source standard, that's one thing, but if it's a closed IP interface, that's probably a little scary, right? But so, what are your take on that when it comes to interfaces?
Yeah, absolutely. You mentioned, documentation about how that component forms or performs and how it could be integrated. I think we have to go way beyond that to the initiatives that we see in the world of protobuf or open API, which I'll get to in a minute. But earlier, there was mention of face and OMS. I think this question about one interface to rule them all, it's the proverbial or metaphorical Lord of the Rings reference there. We know how that works, right? So I don't think it's a could versus should. I think it's an impossibility, right? So in the Department of Defense right now, you have a number of different initiatives that are very, very good initiatives, well-intentioned, but you see a number of problems with them. One problem actually has nothing to do with the specification of the standard. It has to do with just the problem of the passage of time, right? So there's this famous XKCD comic. You've got a situation where there are 14 competing standards, and that's ridiculous. We need to have a new standard to encompass all the standards.
Yeah,
The
but
new
15th
problem
now.
is 15 competing standards, right? So once that standard is adopted and deployed, it's impossible to sunset that standard. And so
Didn't you hear that the DoD CISO just said we don't have enough cyber frameworks? We're gonna do a new one too, just yesterday.
Absolutely.
So I kind of commented on that too. So
Yeah, so I think the single interface approach is just the mistake of the central planner, right? You can't see all the possible worlds where you need to deploy or integrate in. So I think what you need is the ability to tie a standard specification to the standard implementation. So, Brian was mentioning this idea of code generation. I think that code generation technology is very powerful in the interfaces. So you see this in the software as a service world. You have a lot of technologies in this space already, like Swagger, OpenAPI, Protobuf. But those technologies really, they kind of perceive as the protocol is done, it's at rest. But really what we need is not only is this standard specified, but here's how I can version between standards and nuance or variant or extend standards that don't have capabilities that I need for my mission or my deployment. And so I think that's a little bit what Felix was describing earlier. And what we've discovered at Tangram Flex is that when you do this, the articulation of that interface between the embedded component and the larger system is you actually get a whole new breakthrough of your ability to cyber harden and bring a lot more assurance to the correctness of that whole ecosystem. So I think if you were building a software as a service today, you'd know exactly how to deploy it. You'd do infrastructure as code, you'd have GitOps, you have source control, CI/CD. But what would that look like in an embedded systems deployment world? You'd have a full specification of the system where that specification and design of the system maps to the flow of the data between the parts, between the embedded system and its larger ecosystem. You'd be able to specify the state of the hardware. You'd be able to bring that into a testing and emulation world. And you'd have that design linked to the delivered sets of components and functionality. And then finally, moving back to that, NPM Docker Hub vision, you'd have some way to publish that system and the components of that system to a larger ecosystem outside of one company or even one area of the government. You'd be able to share those components, and interoperability is an artifact, or it's a property of that kind of deployment.
yeah, that's very impressive. And so when you look back and you think of some of the engagements you had over the years, and I would argue most people in the in the embedded system world don't even know what protobuf is, and maybe GitOps, and maybe some of the other things you mentioned today. But when you so that kind of get me intrigued, right? What would you say was the most impressive teams that you got to meet, if you can say, of course, that was the most mature in their embedded system kind of agility enablement journey?
Yeah, we're working a number of programs right now that I can't mention here, but are very
Yeah.
exciting. We're seeing the adoption of
What's
containers.
can you say the service, or the, a broader,
The Air Force.
The Air Force? It's always the Air Force, so
Yeah. We're seeing the adoption of containers today in the electronic warfare world. It's very encouraging to us, and they're taking that approach of, we have application software in containers that calls down through firmware calls or operating system calls down to the lower level system. But in general, what we see is teams that are leaning forward, where these technologies, there's a little appetite for innovation, a little appetite for engineering excellence. These innovations allow that team to deliver faster, stronger, better. In fact, this is why our company was created, was our parent company, Gawa, their performance on DARPA HACMs in isolating the specific parts of the system that need to be understood and protected. And so I think it's the best of both worlds. You bring all the strong certification guarantees, you bring all the interface code generation capabilities from industry.
Yeah, no doubt. And I guess I have a follow-up for our friend Felix here. When you think of the interfaces, right? Obviously, John just mentioned a bunch of open source standards. But do you feel like, I'm always worried about the government trying to create some snowflakes, duty specific secret sauce that no one else is using, and compounding the problem, right? Because you're creating a talent bubble, and you're creating something classified, or something that cannot be reused across industry and automotive and space. And it's just, I hate it, right? But do you think there's an opportunity for the open source community to bring options there?
I actually do. I think part of the way we do that is by reaching out to some of the partners in industry, creating a consortium, and just asking the question, what can we do in this space? So, I think that's what's kind of organically happening here. I'm hoping these conversations that we have today, people start communicating and reaching out and saying, why are we doing it this way? Is there a way to incorporate something that doesn't lock us in, for instance, on a particular standard or interface or whatever it may be? And then, whatever the issue is for whomever, for that open use case, how do we overcome it? How do we get to the point where we say, how can I help you overcome that? Not just no, because it's not secure. Or
no, and give up.
Yeah.
So back enough, right?
I think there's opportunity. I think we, presenting in a different way, showing the benefits. One thing I'll say is, if we do have this utopia where we are delivering every 2 weeks, even if there's a vulnerability, right? Like, if I'm deploying every 2 weeks, we've already versioned away from that vulnerability, right? And so,
right.
Hopefully, that communication is happening, and I think we're starting to see it. I know we can't talk very much about particular programs and stuff like that, but it's happening. I think we need to make examples of it as best we can. If we can do capabilities that are out in public, I think that's great too. That way people get excited about it. People start asking questions.
Yeah, that's the other thing, right? The overclassification of things. Sometimes the ability to have case studies that would be fully unclassified would really help show that it's doable. The more people see that it is doable, the more likely it is to happen, right? I get so many CIOs from banking, telcos, and healthcare telling me, hey, if you manage to do DevSecOps for DoD, the largest behemoth, on the planet, you probably can help us with our little bank here, or our big bank here. So it's just interesting to have these use cases available. So let's move to the next topic, which is also very exciting to me, where we talked about kind of all the complexity on all these different moving parts, right? But Felix, when you think about all this, right, who do you think is going to be bringing all this together and remove the complexity so that not every team has to figure this stuff out? I remember, a friend of mine that was at SpaceX, kind of leading, their software work, and he left, after whatever 10 years or whatever, and he went to another space company, and he told me, wow, I was taking for granted all the stuff we built here in enablement, DevSecOps, CI/CD pipeline, cyber, and all the Linux real-time OS stuff they did, and now they they have to start back from zero. And he had 200 plus people at SpaceX, and now you're back to 5 people, because most of the focus on space companies is on the hardware, which is, I think, a big mistake. But whatever. So he's like, I need to find a third party that can just bring me all this stuff turnkey, so I don't have to build it myself. I'm not in the business of, building a DevSecOps stack. So who could I partner with? And it's impossible. There's no one really bring this kind of stuff as a service. So how do we get there? So each DoD teams does not have to figure this stuff out in a vacuum.
Yeah, so I want to highlight different examples across different industries, and then kind of focus in on specifically within the DoD. So if you do some Googling out there, let's bring out a big name like Apple, and specifically emulation, right? So they have, if you guys don't know, they went from an Intel chip, an x86 chip, to their proprietary ARM chip. But most users don't know that, because behind the scenes, they're using a tool called Rosetta, which is emulating the software on your behalf without you knowing it. And so you, as the user, have no idea this is going on. And that's the way they were able to shift away from Intel and into their proprietary use case for them to do what they wanted to do. It's not really talked about a lot, but that's one example of, how they're removing that complexity and bringing things, kind of in-house. So I think that hits home, because everybody really knows Apple and they probably use it. So it's happening right now.
But most people don't have the resources of Apple, though. So
that's
how
true.
do you deal with that with smaller teams? Because that's kind of my fear, right? Is the big guys will figure it out, but we're gonna lose the little guys, and that's bad for innovation, right?
The big guys aren't going to tell you, right? Like, they'll say they're doing it, and they'll bury it,
It's
right?
magic.
They're like,
it's magic.
Yeah, it's magic. It really is, and so, but it does make it hard to learn, especially when it's proprietary and they're not sharing it. So, how do we get there? Who are we talking to? And we have some great ideas that we talked about today, but who do we have to learn from, and what's being highlighted out there? So if you do a little bit of research online, specifically a couple of weeks ago, you looked at General Bunch's exit interview. You'll see a lot of publications out there. One of the headlines that strikes me is modular weapons could improve surge capacity. And then he highlights a specific Vanguard program. And then he says, digital environments can bring different ideas. We can look at those to determine what we want to do and what we want to go out and buy, what gives us the most return of investment, right? So I think highlighting digital, highlighting some of the key things that we talked about here today, DevOps, doesn't go deep into embedded, but I mean, when we talk about these systems, it's pretty obvious, right? So I think this is a good segue here for, someone who's probably in this space a lot, and that's probably our next guest.
Yeah. And I'm so excited to have him, because I like people that do stuff. I'm good at talking about other people's work and take credit for it, right? But let's bring Jorge his, and I have so many questions for him, and I think the public also has a lot of questions that I see here. But when you hear all the different topics we talked about, first, it's a pretty complex problem, a lot of commercial IP, a lot of legacy things, a lot of newer way of thinking that are disrupting the legacy companies that don't like to be disrupted, and some would prefer to put their hand in the sand, pretend it's not happening, but it is happening regardless. Of course, the more competition, the better, right, for the government standpoint. So when you look at the adoption of all these things we talked about today, how is that going, you feel, in the government today?
Well, thank you, Nick. And I think, when Dr. Roper penned Bend the Spoon, and when General Brown came out with his Accelerate Change or Lose initiative, right? Those are key indications that we are kind of lagging behind, and that we need to keep pace and outpace our adversaries, and keep pace and outpace, hopefully, even the state of the world that we're seeing, especially with embedded systems and software development. So, the government is a large entity. It's a robust organization. You can probably attest more than anyone else. And it's difficult to try to steer that boat, if you will. But getting the word out, right? And I think when we started this conversation, you talked about educating yourself, right? Getting the word out and educating yourself, I think, are critical things that are going on right now. And we are making strides in that direction. So getting more teams educated on what the state of the world is, what the newest tool sets are, and how we can implement those into our programs is going on right now. And it's breaking some ground, at least.
Yeah, so that's great news, right? So but then you're thinking, okay, what's next, right? So what do you think the government could do to do better at removing some of this? Sometimes the government get in the way of common sense, or get in the way of innovation through our own mistakes or own misunderstanding, lack of training. That's why I've been focusing on this course, because obviously it's not to make more money. I don't care, but it's really to make sure that people get the training they need, because I really go back to unbiased training that's not pushing the secret sauce of Microsoft or Amazon or Google or whatever, right? And so when you look at the lack of training of some of the leaders and even the middle tier rank, I guess, what do you think the government could do to remove some of these impediments for that adoption to scale?
That's a good question. Felix kind of highlighted one of the critical actions here, and that's to build out reference architectures, right? So as we build our systems, is there a way for us to design a reference architecture that enables us to clearly articulate what we want and desire, kind of frame the problem set a bit, and then maximize the ability for reuse down the way? I think that's a critical action that we can take going forward. Would
you use? No, I'm sorry to cut you off, but would you use OMS, and the work that's been done on that side of the house, by LCU and the teams? And is that a good example of an architecture to enable reuse, or are you thinking of something different?
No, so there's a number of top level architectures. There's avionics architectures. There's architectures out for EW type solutions or munitions. And those are really trying to scope the way that we build and articulate the way that we build our systems, right? Decomposing them into bite-sized chunks so we can put them back together in the Lego bricks that you described earlier on. And then you can go a level down, right, to things like OMS space, some of the standards that are out there that enable you to
broader and then more granular. Okay,
more granular, right? Some of those implementation strategies that make it a good starting point from a program office to start from. So I definitely think if you start,
do you think they're going to get? I mean, are we able to keep up with those so they don't get stale? And because the bureaucracy, we create good ideas and good documentation, just like I did with the reference design for DevSecOps, and then it's not been updated since I left, which is probably not a good idea, right? Mm-hmm. So how do we make sure it doesn't become part of the problem?
Yeah, we need to level up, right? I think you're hitting the nail on the head with education, right? An hour a day. I will be honest. I spend 2.5, sometimes 3 hours in the evenings just trying to keep up with folks like Felix, right? Whether that's online and searching in IEEE, or whether that's looking at our implementation strategies and trying to find efficiencies. So we definitely have to keep pace and educate ourselves in order to maintain this tactical relevance, if you will, right, of these solutions. If you let it grow stale, it will not be tactically relevant when you need it. So we have to keep pace with them and have dedicated teams working on these, I think, is one key aspect.
But you're a special talent in the Air Force. I mean, we have a lot of great people, but the fact is you're special. But when you look at others, do you find the same eagerness to learn? My fear is I've seen, unfortunately, everywhere, not just in the Air Force, but in many organizations, even in IT, which is kind of a little surprising. Particularly when people don't have the passion behind it, right? I think when you're passionate, it's not a pain to learn. But I found a lot of people that are not passionate about the work, and so they have a tough time to reinvent themselves and learn. What do you tell? How do you help those people? Because we can't succeed without everybody being part of the same engagement. So how do we bring them with us?
Yeah, collaboration, right? So getting the word out and showing that folks can come, and we can have a lot of times we'll call them collider events, right? We'll bring in a whole bunch of partners across the government, and we'll just describe what we're doing and how we're implementing, right? And trying to leverage those best practices. I will tell you, a lot of folks aren't incentivized. They are learning. They are trying their best, right, to get out in front of a lot of these technical advancements, but they're not incentivized to do that, right? They are maintaining a static legacy baseline, and to some extent, those folks kind of have to keep their head in the sand, as you described. But at the same time, they're reaching out, right? They're trying to make those strides across the services, right, across the DoD, across the government, trying to educate themselves and then come up with efficient strategies to maintain even our legacy systems.
Yeah, no doubt. All right. So next question for you. When you think of that future implementation, you talk about the reference designs and the architecture and all the things that needs to be there to enable this at real scale. Because honestly, when you look at the success stories we have, which is why I kind of got frustrated and ended up leaving, is because the leadership was always agreeing that all this is essential, but yet they would not mandate it or make it the norm of doing business. And so we would still have the bulk of the money of DoD being spent on the waterfall, non-agile way. And of course, if you want to get to where you want to be to win a fight against China 20 years from now for our kids, you have to do it at scale. And so when you look at that future implementation, right, first, do you have a good grasp of what it looks like, and how close do you think we are of getting there versus still daydreaming?
So ideally, we're not daydreaming anymore, right? I think General Bunch's exit interview is pretty clear, right? There's a clear view on where we need to go and how to get there. The hard part is doing the proof of concepts, right? Doing the risk reduction, showing folks that it's executable, and then scaling that solution set. So I definitely see the future being that highly modular, right, highly segmented capability that we can port in intellectual property, right? Containerization, and what we've just learned today is pretty revolutionary, right? And some folks will feel that they're stuck between a rock and a hard place, right? And these new technologies allow you to remove a lot of those barriers and maximize the ability to integrate new and novel technologies very quickly. So I definitely see the future being far more reuse across mission areas, across services, starting a program, right, and understanding your requirement sets through rapid prototyping, so that you can really understand how that requirement is going to evolve, right? It has never been, we are living in a time where it has never been easier to go from idea to solution. You can hop online and find someone's IEEE paper that they wrote, and then you can go to GitHub and you can find the source code, right? Their open source code that they're implementing. You can port that to a dev board, and you can do that pretty seamlessly today. So our ability to kind of take those lessons learned, those approaches, right, and integrate them into our programs, I think is going to be critical as we move forward. We're definitely getting close. As Felix described, there's a number of programs, and as a lot of the other guests described, there's a number of programs in the U.S. Air Force where we're getting there. And now you're starting to see some momentum, right? The proof of concept is done. Now let's start to take that recipe and cross-pollinate it across the DoD.
Yeah, and that's kind of the thing, right? At first, people wanted examples, and then they got a bunch of examples, but yet, there was still no eagerness to make it the norm, and that's kind of what got me frustrated. But I think, thanks to my engagements now, I was able to really educate a lot of people. But the problem goes back beyond the Air Force leaders. It's really also how Congress fund things. I might think about giving my courses at no cost to the staffers of Congress, because at the end of the day, if they were maybe a little bit more stringent on how people should be reusing existing capabilities to fund new programs and break some of these silos and think more as enterprise capabilities and reuse, instead of funding siloed programs, which effectively are, by the way, taught by the Defense Acquisition University not to use enterprise services because it creates a dependency on something that's uncertain and not maybe properly funded. And I've heard countless material leaders and senior material leaders tell me that they don't want to use enterprise services because they've been taught for years, decades, that they're not reliable. And so that's obviously something we have to fix, right? Because you can't have reuse if you don't have also the right enterprise services to streamline the adoption of everything we talked about. That includes, of course, the proper cloud office, the proper DevSecOps office, with Platform One and Cloud One, but that also includes, the MBSE multi-tenant kind of universe where you can have all the digital twin tools and all at all classification levels, and really streamlining the adoption of these technologies so that many of these will be easily consumed by the programs. I also hope that some of the more legacy older companies start moving away from kind of the stuck in time Windows universe and start pushing maybe a little bit more cloud native multi-tenant solutions as well. But when you look at an example we kind of kept using for good reason, because I also found out that when I use Netflix as an example, of course the objection of the leadership is going to be, well, we're not here to build freaking video apps, right? Which is not false. So I find both SpaceX and Tesla to be better examples for the DoD. I did a whole video segment on my training course about how to get momentum with the leadership and how to get them to understand the problem and care and help you get where you want to go, right? And so that's kind of the vision we have when it comes to the adoption of digital transformation. When you think of SpaceX, and we talk about some of the numbers, right, with 17,000 build of software a day, 3 hardware in the loop testing a day, the ability to have the digital twin representation, update software a few hours before the launch, right? With no higher risk. People think, oh, that's criminal, right? But the fact is, there was never an actual software issue with the launch. So when you compare us and what you see, maybe on the best, let's pick not the worst because that would be unfair, but if you pick the best engagements you've seen in DoD, how do we compare with the SpaceX?
Yeah, so it's a little bit of an apples to orange comparison, right? A launch vehicle versus a combat platform that's designed to go into a highly contested environment. They do have their differences, but I think the premise of your question definitely resonates, right? So how do we become much more flexible, right? How can we deliver solutions at a tactically relevant pace? How can we not just keep pace with the adversary, but outpace the adversary when the time comes? Those are critical functions that we absolutely need to be baking into our programs now, and building out families of systems, right? So you can think of each mission area kind of building out their own family of systems, and then from mission area to mission area, you have that reuse, which can maximize opportunities. So are we getting to the point where we can tactically deploy software solutions in a rapid fashion? We're getting there. Do we have a long way to go? Without a doubt, right? Can we continue to identify and leverage the commercial trends that we're seeing? Without a doubt. We should be looking at the commercial implementation strategies that we see across the board, taking those best practices and implementing them within our programs to cut costs down, right? To generate capability faster, and really to be able to get out in front of the threats that we're faced with.
And of course, we do have the Space Force in the Department of the Air Force, and so that would potentially align a little bit better, right, to the mission of SpaceX. Of course, you're in the Air Force on the Air Force side, but have you had good interactions with the space side of the house to see what's happening there?
Yeah, so we're seeing a lot of, and it's been a while since I've stepped back into to the space world, but you are seeing a lot of secondary payloads getting access to space, right? So more commercial access to space, more satellites being launched and getting access to space. So I definitely think that from that perspective, we're making huge strides in ensuring that we have enough access to space for all of the DoD. So it's a pretty robust time to be in the space world right now.
Yeah, it's pretty exciting times, right? You see the velocity of innovation and what's happening also on the commercial side of space is kind of it's a market ripe for innovation. And quite honestly, I think that the software-defined world in space is vastly misunderstood or misvalued, and I think people are gonna have a pretty hard awakening when I look at some of the companies out that invest drastically in hardware and kind of forget also the cyber side of the house, but also like the DevSecOps side of the house, and kind of the software at scale, right? And the enablement of that velocity of software. I was looking at some data that someone sent me when you compare NASA with SpaceX, which of course NASA people forget, but initially made fun of SpaceX, saying that landing back a rocket would never exist. So that also tells you, like, people that tell you that whatever you're thinking about is not doable. You want to push back to the side and keep moving, right? Because you don't want to listen to people that don't do much. So there's a overrun cost comparison of NASA versus SpaceX, where the median cost overrun of NASA is 45% versus 1.5% of SpaceX, and 9 out of 10 projects of NASA have that 45% average overrun costs, versus 5 out of 10 of SpaceX have this 1.5%, which is, I don't know if we can even think of 1.5% as an overrun cost, because it's so negligible. I would take it all day long, I can tell you that. But I think that's another kind of interesting piece of data for the audience. So now we're gonna take and if you have a last thought, I take it now, and then we're gonna go to questions from the audience.
It's the commercial macroeconomics, right? If 45% overrun, it's not going to make me profitable. So you got to drive those costs down, and you're incentivized to do so.
All right, so I'm gonna bring everybody back because we're gonna have questions from the audience, and I'm not sure who's gonna answer what, but let's see. Let's start here. How do you make the decision when choosing between processor power, like CPU versus microcontroller? And same question between the type of operating system versus embedded firmware. Who wants to take it? I know it's an interesting question.
So I'll give it a stab, Nick. So on the choice of CPU versus microcontroller, I think the price tag is going to be a part of it, but also you need to look at the specification of the device itself. Felix gave a good example of a handheld device. You may have much more constraints, and that will steer you towards something that's smaller in size. But if you make a ballistic missile, you have a lot more ability to put something. So there's going to be some aspects of it that are going to be mechanical, and obviously the price is going to be a big factor there. Now, also in terms of to be very, very specific, there's going to be logistical aspect. Can you order in quantities? What are the availability? So this is mostly, in my opinion, more of a supply chain issue attached to a set of specification from the end device. Now, on the software side, which is something that I am personally much more familiar with, right? It's, I think, going to be a decision of what is the right thing. A point that I heard today many times that completely agrees, we shouldn't do the things just because it was the way it was done yesterday. We don't have to blindly accept last year we did this, therefore we have to redo it. Now, we need to take into consideration the needs and whether or not the new nail is better than the old nail. Right. At the end of the day, from an operating system point of view, you will have some constraints, and it is always key to look at what is the end goal. If my end goal is to be doing something that's going to be evolving very, very rapidly with the need to integrate a fairly large amount of known and existing open source software, that might guide you in a certain direction. Now, if your specifics are highly critical and looking at timing requirements that are stringent and must have, you may have to steer your software decision towards a slightly different set of solutions. So we talked about the standard that rules them all. In the end, it's always about common sense and trying to just adapt the solution to the problem, and not just trying to look at something we personally like and say, I'm going to try to make it work just because I like it. So at the end of the day, it sounds probably like an answer that, hey, you get to make the decision. I really believe it. There's no one size fits all. And we always need to look at the future, where we want to go, what are our KPIs, and then make that decision, not just always look back and just Control C, Control V, right? Copy paste just for the sake of copy pasting, right? So it's a politician's, what I would call a politician's answer, but at the end of the day, your mileage may vary greatly depending on what you're trying to achieve. I don't know if others have more pointed point of views here.
Yeah, I guess I'll add one more comment, right? So the good news is you can begin developing the application in SCADE before you even make that decision, right? Whether it's a processor running an RTOS or a microcontroller running firmware or bare metal, as it's called, that really doesn't matter. So you can certainly get ahead on that from that standpoint.
So, and I think swap comes into play as you know, space, weight, power, all that, and specifically when you look at you're using something like a hypervisor where you can collapse more software operating systems onto, you know, maybe higher powered device, that helps with that, right? So instead of having to put many more modules out there, you can utilize the hardware better with multi-core and a hypervisor type of environment.
And there's another point that comes to the comment that was just made that is very important, is if you don't know yet, that was something we brought up earlier. Hardware simulation or emulation can help make some of these decisions. You can write a software ahead of that decision, and using a software simulation environment in a cloud native way, you can make multiple tests, multiple runs, and start evaluating some of these KPIs based on what the needs of the end applications are before you made that decision. So you can early prototype, pivot as necessary before just making a decision 9 months later, realize, oh, that was a bad decision. So you can have that iterative approach that is really, the opposite of the waterfall, where you make a decision, you walk down the left side of the V, then right time of the V. Then in this way, you can just do this iterative process, leveraging additional tools, including modeling of the software and simulation, emulation of the hardware.
Yeah, and Michel talked about common sense, which I found out is not that common, by the way. But and also you talked about personal preference and bias, right? I think that's probably what I see the most, and also what I also see is you don't know what you don't know, so you end up picking what you know, which might not be the right choice. So there's back to learning and back to diversity of options, and also not always listening to your personal preference, right? But unfortunately, common sense, like I said, is not always there. So there is a question from Alex here, which ties back a little bit to this, right? And I'm going to give it a shot at the answer too. But he's asking, what is the scale of containers being used in the embedded world? I assume that's pretty inexistent today, but that's going to probably change. But so obviously, Wind River is working in that direction. What about the bigger picture? You mentioned that containers are kind of heavy for embedded environments. And then if we continue that path, is it feasible to fully utilize Kubernetes on such hardware and micro Kubernetes, K3S, and all the other, mini Kubernetes distributions? How good is that? I'm going to also add a piece to that. I did a video on why Kubernetes is a must to build pretty much most kind of capabilities, also on the cyber benefits, but also on the orchestration benefits, the ability to do update of the container stack on top, right? So like the flexibility that you get, right? Comparing Kubernetes and containers with just bare metal something is pretty unfair, right? Because you're losing the service mesh, you're losing all the benefits of Kubernetes in terms of abstraction and in terms of auto scalability, disaster recovery, self-healing capabilities, and so on. So all these things, you would have to bring them in a different way, which often people bring through code, and I would argue is also creating a massive kind of a massive chip impact and memory impact, and so it's just pretty unfair to just dismiss it as something you wouldn't need. So you would probably still want to have some of that stuff orchestrated in a different way. So who wants to take a stab at this?
We kind of mentioned Wind River, so
Yeah,
Don't wanna steal your
I'll
thunder.
give it a shot. Yeah, thanks. So obviously, I think we answered the question in the embedded world, right? So the ability to deploy a container using IT-like environments is already there today. Where is it going to be in 3 years? It's a different story. It's a matter of how much hesitancy there is to adoption. And I'm very pleased to see that some of our partners in the defense world are truly adopting it. And obviously, you mentioned that we're moving into the umbrella of an automotive company. Their Aptiv is indeed heavily looking at leveraging containers for that. So I'm personally pleased that the world is recognizing that a technology that was, no pun intended, battle tested by the Amazons and Googles of the world is now going to be used in a non-traditional fashion for this particular type of technology. As to the applicability of Kubernetes and is it too big, I think we can apply the same logic that we did for containers themselves, which is to not make a blanket statement as do I need Kubernetes as it is today, but is there a subset of Kubernetes that is relevant? And then start from that subset and build up, as opposed to trying to do it all and spend a fairly large amount of time. Let's focus on a few use cases where there is relevance, where there is applicability, and then you build up from there, using, as usual, some of the metrics that we want and essentially expand, as opposed to just trying to build a crystal castle that essentially nobody would inhabit in the future.
So
Yeah,
when you
probably
talk
don't want to
about
bring a bloated OpenShift. You probably don't want to bring a bloated distribution like the full stack OpenShift on an embedded system. That would be pretty painful, that's for sure.
That
So
is
go ahead,
correct.
Felix. Sorry.
so when you're talking about certification and the containers, are we just talking on the deployment side, or are we also talking on the actual running on the device?
In this
I think
case,
it's
Felix,
both,
we're
yeah.
looking, it is both, but from a very practical point of view, where you look at certification, that's going to be the device, right? How can we have a cloud native environment that is offering a continuum all the way to the device, so that, from your development cycle, your deployment cycle, and your operation cycle, you use the same type of technologies. And containers really lend themselves very well to that. Although as you get to the device, you're going to start to pare down a little bit the feature functions. Nick mentioned footprint, right? The requirement, one of the KPIs we had for the container engine for the RTOS was it cannot be above 100 kilobytes. And I said kilobytes, not megabytes, right? Kilobytes. So obviously, if you compare it to Docker and something else, that's really not the same scale. So the question is the same for micro Kubernetes. At what point do we have enough functionality, and how do you make sure that that is offering a continuum all the way from the engineer to the battlefield, right? And so it's always about matching a particular feature to use case, and making sure that we don't make these promises of trying to do it all. And that's kind of where we're trying to go, right? So that's why it's a work in progress. That's why I mentioned earlier that finish line is probably going to move as we're running towards it. But we don't want to wait until the finish line has been drawn and say, okay, now that it's somewhere, let's start running. We got to start running, essentially try to get there, with our customers and with the rest of the technology world.
And John, what are your thoughts on all this?
Absolutely relevant. Great question. We actually use K3s here locally. We develop an application that is deployed in GovCloud on a full Kubernetes deployment, but locally all of our engineers are able to leverage the exact same technology stack. So I think that the strategy of paring down the Kubernetes distribution for the use case, I don't think K3s is going to get anywhere near the 100K limit, but there are things that you can remove. Do you need event auditing of your data plane when you're running? Maybe not. Do you need the entire kernel? Are you going to take an approach like gvisor, runs? It sounds like the Wind River product is more towards that direction. So I think there's
But do you think we should rethink the like the 100K? Is that if we remove security things that are beneficial to the safety and the cyber, because cybersecurity is as dangerous to me as something else. But are we creating just bad behavior? Is it should we not update the standards instead of like removing pretty important stuff?
Yeah, I think you may look at, do we need to bring more hardware into play for the kinds of capabilities that we need for our orchestration layer? I think you brought up a great point, Nick, which is if you don't have those orchestration functions, you're going to implement them probably poorly, and in a proprietary fashion. So you're going to need some of the orchestration capabilities you get with the paradigm of Kubernetes, but you're not going to need the entire stack, right? So there's parts of K8s that you probably don't need to bring with you.
Yeah, but you also don't want to remove stuff just because of that 100K. I mean, I'm all about making it very modular and flexible. Don't get me wrong, but I think like it's kind of the wrong behavior to start pushing people to remove stuff just for the heck of that 100K number that came probably out of someone's hat. I don't know if that would be still relevant in 2022 with the modern real-time OS chips and things that's going on nowadays. So what do you think, I guess, Michelle, when it comes to that limit? Should people, who even defined it, and should we change that?
That's a good question. So it was defined by a set of our customers, but the way I look at it is to give a goalpost, right? It's going to go beyond it. The point was to try to challenge us in the right way, as opposed to just looking at the status quo. So 100 kilobytes for the initial drop, considering the cost of safety certification, was already an expensive proposition. Now, as we add feature, it's going to grow. It is not a hard limit, and you have a real good point. Today, that's the limit. Tomorrow, it may be 200, and by the time we hit the end of next year, right, it's going to be 4 megs. The point is, we had to start somewhere, and the only way was to ask the end user, the customers who were willing to deploy it, say, okay, what would you accept? What would be the right level of, additional software you want to do? I do not believe we're going to compromise anything. Again, it's always a matter of making the right choices initially. And so we're building up, and you're at some of the elements we're adding will blow that size way up, but not to the gigabytes, right? So we're trying to remain between the super low and the acceptable.
Could you think of it kind of like building kernels, right? So I know when you're building kernels, you just put in the capability that you need, like networking, or if you're not even using that, then why include that as part of your kernel, your custom kernel, and then you just continue to have a small footprint? Is that the same with, like, say, Kubernetes that you guys are implementing?
I mean,
yeah, that's the same approach, right? It's more of a reducing the attack surface by removing the feature function that the end user indicated they don't need. Now, as this is changing, I think, and we are seeing that as the technology is being used and people are starting to realize, yes, this is useful, yes, we can make it, because we're also fighting our own biases, right? Where we're saying that, okay, now I want more. And they start seeing the benefits. So again, we're walking with the customers, helping them move to the next step, and essentially getting to the point where, yes, I can use it, as opposed to making a statement, say, I'm going to deploy X, Y, or Z feature in a system without knowing all the input parameters and how it's going to be deployed. So we're trying, and this is probably because of my product management hat, right? I look at it very practically. How can I build a product that our customers will be delighted to use, that enables them to go into the future, as opposed to just keep them where they are? So we need to start at a small place. And to Felix's point, we start adding, in a CI/CD fashion. You add more, you iterate. You add more, you iterate, until the point you get to a solution that is effectively what the market needs.
Yeah. So last question, because I know we're going to run out of time, but I have one last that I'm going to bring up. What would having more operating systems and more differentiation, more options be helpful? What do you guys think? Or do we already have too many, and it's just already enough problems like that?
Do we need like variations of the same kind of kernel like Linux, or just something completely different? I think
I don't know. You didn't precise, but I would hope it would be something that's not just ego driven or like IP driven or something that's
So
a little
there's
bit
like
more practical.
I don't know what you guys think. One of the challenges I see, and I think, Nick, this is a point you bring often, is the integration. The PCs sometimes exist, but then getting them to always work together requires a lot of training, lots of education, and maybe sometimes why people are reluctant to use it because it's unknown. So I don't know if it's all about differentiation. It's more about, in my opinion, about integration. And how do you provide something that works right away with the right level of security, where you can do your updates, where you can innovate? So that level of integration is probably where the value gets added, not necessarily yet another operating system. We have Linux that provides a fairly large amount of solutions to a fairly large amount of problems. And for these problems that cannot be solved with just an off-the-shelf open source environment, there's certainly a set of technologies that are more proprietary, more bespoke, that, at this point, the sky is the limit as to how much customization you want to do. But that's again a selfish product management thing. I look at the value stack, trying to make sure that the end user is satisfied rather than just adding a feature.
What's interesting too, right, is I feel that's not where the problem really is, right? Back to my point is, now that companies are going to be expected to do over the update and bring more security, that's going to obviously make the whole orchestration stack a must, because you can do over the update in the wrong setting and the wrong cyber stack and the wrong enforcement of provenance and signatures and all the stuff you want to make sure that no one tampered with before doing an update, and all that orchestration of self-healing and how to do it with no impact to the runtime. And so I think my take is we're gonna need to see companies that start bringing the upper layers, not so much the OS layer, but more like DevSecOps as a service, but designed for the embedded space, and then maybe with a cloud environment that can be used for the development teams, with a digital twin capability there, and ability to push straight to the lab and for hardware in the loop testing and straight to production to deliver over the air stuff. Maybe partnering with Amazon and Azure, space ground station stuff, right? I don't know, right? But there's going to be a need of like a platform service player that's going to make all this stuff easily accessible for the smaller companies. And then of course, managing the service mesh and all the cyber stacks, the zero trust stack, authentication, identity management, short-lived identities if you're moving to containers, and cattle versus pet, and all these certificates and keys. And there's going to be a need of having a company that's going to be bringing this turnkey to the industry, I think. So what are your thoughts?
Yeah, I think this is what we're kind of trying to do with this platform that we have. We call Winiverse Studio, right? Where it's the entire DevSecOps as a service, if you will. We build, obviously, using the assets Winiver has been traditionally known for, but integrating elements of simulation as well to accelerate the development. So the entire CD things. And this is kind of what I mean by integration, quite frankly, is where you get to the point where all the PCs are there and fully integrated from the time you write a line of code to post the deployment, where you have to go back to your code to re-update it. So I completely agree with you, Nick. At the end of the day, the value is going to be more into providing an end-to-end solution that really allows the end user to do everything in between, just writing the code and all the way to getting the platform developed, whatever means are necessary in between, and providing that level of maintenance and security and immutability when necessary and where necessary. All these building blocks together absolutely makes a whole lot of sense to me.
Yeah. So I know we're out of time, so I'm gonna do a couple of things. First, I'm gonna thank you all for joining, and thank you so much for the time. I wanted to especially thank the two government people here, because it takes a special person to stay in the government and really make a difference, both on the military and the civilian side. So I wanted to thank you for making our nation safer, and all the work you've been doing. For people that don't know, Felix has been helping me all the way back to when I was in the government to lead the embedded system DSOG team that was part of the team I pushed, right? And to start already doing a committee of practice and engagements across industry to bring embedded systems to the broader DoD. So he's been doing amazing work, of course, and and he organized this event here with the great people that we have on today. So I wanted to thank you again, both, for your service. Last thing I'm going to do also is I'm going to let people know, before I let Felix do the closing, because I always let the guest do the final closing. Next Tuesday, I think you're going to like my next guest at 1 p.m. on Tuesday. Danny Holzman, the authorizing official for most of the Air Force Contours ATO programs, whether it's Cloud One, Platform One, Kessel Run, Space Camp, F-35, GBSD. Some of the most critical programs out there are accredited by his office, and he's been kind of the father with Lauren and I of the Contours ATO process, and so he's going to be on the show to talk about all that. So it's going to be a pretty interesting discussion. But now over to you, Felix, for the parting words. Thank you so much for joining.
Yeah, it's been my pleasure. Thank you for having me. I'm great that you're still involved and bringing light to this subject. I want to thank everybody who joined today. Kind of short notice to get everybody on, and I think we need this is an example that we need a community to solve these problems. It's not going to be one person, one platform, one program. It really takes everybody to get the job done. So I appreciate that. And then for the folks who support me, within my organization, extraordinary group of people, XG, I just want to thank everybody, and hopefully this starts conversations. Reach out to me, reach out to anybody. Let's just have these talks. I'm willing to hear you out. I'm willing to work with you. I'm excited about the topic, and let's roll up our sleeves. Let's get to work.
All right, everybody. Thanks so much. See you next week, 1 p.m. Tuesday with Danny Holzman. It's going to be a very fun session. I hope you learned something today, and keep learning, invest in yourself, and don't let anyone tell you cannot get where you want to go. Otherwise, we're never going to succeed, and keep fighting to make sure our nation has a fighting chance at winning against China 20 years from now. Thanks, everybody. Stay safe.
Thank you.
Thank you.
Thank you.
Thank you.